everyone. Right, we're excited to have you all in this session. I'm Bernard Harguindeguy with Ping Identity, and today we're very lucky to have Param, who is Chief Security Information Officer at Entegris, and Manoj Kona, who is leading the data integration efforts at Ciena. So before we start, Param, do you want to give a quick view of your background for the audience, and then during that time I'll set up the presentation.
Yeah, absolutely. Good morning, good afternoon, everyone. Delighted to be here today. As Bernard shared, I'm the CISO for Entegris. Entegris provides advanced materials to the semiconductor industry. And prior to joining Entegris, I was in GE, and in there I had an opportunity to take on and evaluate the challenge of APIs, their discovery, their protection, their governance. So really looking forward to a thought-provoking dialogue here with Bernard and Manoj.
Thank you, Param. What about you, Manoj? Quick intro?
Hello, everybody. Good morning, good evening, wherever you are. My name is Manoj Kona. I'm currently a Director of Data Integration at Ciena. Ciena is a large 5G global cloud connectivity networking giant. Prior to Ciena, I was the leader of integration team at NOV, which is a large Fortune 500 company that catered to the needs of upstream oil and gas industry. Over there, I was able to work on various IT, cloud, and digital transformation initiatives where API infrastructure that we set up played a key role. And very much excited to be part of this discussion to be able to share my experiences around API security, strategy, and governance.
Thank you, Manoj. And sorry about that, guys. As you can tell, right, both Param and Manoj have extensive experience with the security of API at scale, sync, multiple clouds, hybrid environments, right? So we had a lot of questions from the audience that came in via the conference, and one of the first one is really about how do you get started when you think about API security? What's the best way to get going? Param, do you want to take that one?
Yeah, sure, Bernard. I think it's important for us to look at APIs and think about them as any digital asset, and therefore manage the security of it along with its life cycle. So think about APIs in their two phases, pre-deployment and post-deployment. As you are thinking about engineering them, think about how you can code them securely, how you can drive right authentications to them, how you can ensure that they have access just to the right amount of information needed. And once they are deployed, think about how you can get visibility to where they are, how are they being used, who is accessing them. Do you have the ability to see the monitor the traffic of all of that volume and velocity at a given point of time? So taking that life cycle approach for your organization and scaling it to how your organization can best support can be a great starting point, Bernard.
Yes, thank you, Param. And then you bring up two interesting points, right? And I like to think of API security that way, right? There's a visibility component, right? You got to know what's going on your APIs. You got to know where the APIs are. That you have APIs you don't know about, right? So discovery is important. Knowing how to track the traffic on those APIs, being able to have some forensic data, right? Something happened, and so all in the category of visibility. And then you have the ability. The next one is, do you have the ability to understand if something is not going well with your APIs, right? Can you detect this in real time or near real time? And that's the second aspect of API security. So maybe, Manoj, a question for you. when you approached API security, what were the major risks that you were trying to address and manage for your organization?
There are common traditional risks associated with API security, right? Like, for example, making sure the PII data is blocked, making sure the application support pagination, making sure TLS is supported both in north-south as well as east-west traffic with the advent of microservices and cloud-native architectures. And then making sure, common API security issues, whether it be related to injection or cross-site scripting, are taken care of. But in addition to these traditional checks and balances that you have around API security, I would suggest leveraging an AI ML based behavior based analysis and applying that analysis to detecting and blocking threats, because there is only so much you can do with static threat checks or things that come out of the box using web application firewalls. Uh, they're good when it comes to detecting and blocking static threats, but they're not good when it comes to learning about threat in real time. So identifying and blocking threats to API infrastructure based on behavior analysis with machine learning is essential in addition to these other traditional methods. And at the same time, some of the common ones, authenticating and authorizing each access, leveraging automation, CI/CD, and other things to do governance around APIs. Because once you are trying to scale your API infrastructure, manual intervention is not going to scale your infrastructure. So leveraging automation is extremely important. Track all API transactions per user, not just tokens, cookies, IPs, or keys. And also, have that single pane of glass across your multi-cloud as well as on-prem as well as colo data centers.
This is good, Manoj. In fact, so I couldn't agree more, obviously, regarding the use of AI analytics to understand if something is not normal with your API. And you approach a really big point, which is what most experts talk about, the security gap or the API security gap, which means that maybe the most common misconception about API security is that one can rely on their WAF or WAP, right, infrastructure to protect their APIs. And as you said, the biggest downside of that is that it's rule-based. So it's only going to be able to recognize things that they already know about, right? Attack patterns that are known or that are being, programmed into and then maintained into the device. And so the issue with this, obviously, is that if you get someone who is coming in that with an attack that's never been seen, which is almost always the case, you cannot block it at the WAF level. So relying on a WAF alone to give you this level of API protection is not enough. And you need to add another layer at the minimum that relies on being able to detect the unknown, which is why most often API breaches are undetected. And so to this point, maybe I'll go back to Param about, what are the most common bug found in APIs, because one way to breach is to attack the API, find a vulnerability, and then get in. So what are the most common bugs that are out there in the API world?
So I heard your question. What are some of the common bugs out there in the API world? Okay. So I think, Bernard, there are two ways an API can be exploited or abused. One is an intentional abuse from the outside, like you were just sharing in Manoj, where someone is trying to attack or brute force enter or take over the identity. The other area where APIs can be abused are purely from engineering defaults, right? Engineering of an API may not have been done properly. So it is possible when the API was engineered, it resulted in wrong data being sent to the wrong user, or the data being sent to a user who was not authorized to receive it. Or in a very regulatory environment, APIs are sending more information than is intended, creating other compliance issues. We also are seeing scenarios where an API may have a bug that excessively results in flooding of the network, creating denial of service unintentionally, but as a consequence of that bug. Or we see scenarios where a partner who is using, or the third party that's using the recipient side of the API is not really using it in an ethical way. I mean, the example of Cambridge and Facebook just comes to mind right off the bat there. Many times we think about API as a pipe and focus on its protection, but we forget about the two endpoints of the sending and the receiving UIs. If their engineering is not secure, they can be conduit for entry into APIs. So I think secure engineering practices, testing APIs in that engineering state before it is deployed at all states in all functionalities really helps us kind of take a better proactive approach towards minimizing those bugs. Bernard.
Yeah, that's this is a really good point, Param. And the fact is that APIs are coded by human beings. They're tested by human beings. So unless you can really automate really good tests for security and vulnerability, you're bound to end up with bugs in production. So you have to be able to, one, deploy in production tools that will let you know that something is not right with your API. The sort of thing that Param just mentioned, right? Am I delivering data to the wrong person? By the way, I've seen this personally happen in one of our accounts, right? It's a bug. It's not a hack. And as Param said, right, good API security starts with strongly authenticating and authorizing, right? If you do not properly authenticate and authorize access, then you're bound to have a breach. And authorization is probably the most common bug I see out there. It's a lack of authorization. And we've seen some big cases in the news at the end of last year, especially with Peloton, if you remember, right? When the news was everyone can access Joe Biden account on a Peloton bike application. And that's because there was a lack of proper authorization coding, right? What the OWASP top 10 API list will call BOLA, or broken object level authorization. So good authentication, good authorization, the ability to see if there is an abnormal behavior in production in order to catch those bugs is very important. So definitely part of the 101 of setting up a good API environment. Manoj, maybe I ask you, zero trust model, right? We hear a lot about that. It makes a ton of sense, obviously. Does it apply to API security?
So zero trust is extremely important as software and apps aren't contained in a fixed network anymore, right? They are in multi-cloud, they are in multiple data centers and colo centers for a particular organization. And threats do exist throughout the application and infrastructure stack. So the driving force behind zero trust is to secure a software system by eliminating trust from that system. In contrast to traditional perimeter-based security models, zero trust is based on the premise that location isn't relevant, and users and devices can't be trusted unless they are authenticated and authorized. So zero trust, as you can see, very much applies to API-driven world. An API-driven application can have thousands of microservices, making it difficult for security teams, architects, operations, and engineering leaders to track all development and their security impact. So adopting a zero trust set of principles ensures that each microservice communicates with least privilege, preventing the use of open ports and enabling authentication and authorization across each APIs. At the end of the day, the goal is to make sure that one insecure API doesn't become the weakest link, compromising the entire application and data. Zero trust makes more sense today than ever. More and more applications and services are composed of disparate system components that call each other at the behest of millions of users, and any of whom could be a bad actor. It kind of like needle in a haystack problem, attempting to exploit the application and steal precious data. So these applications communicate mostly via APIs. So it is imperative to apply zero trust concepts.
You made some really strong points there, Manoj. And I'm going to add one thing, right? The most common API attacks happening with hackers that have real credentials. So either they stole them, right, via phishing, or they bought them, right? And that's common, right? Don't think it's it's common. So or sometime they create their own account and log in. But imagine a hacker coming in with real credentials that were stolen, right? If you do apply the zero trust model, meaning you're going to really double check that user, you're going to do a risk analysis on that user before you finalize the authentication and authorization, then a hacker with stolen credential is first not likely to be in the same location as the real owner of the credential, right? Let's say the owner is in San Francisco, hacker is in, Dallas, and he's coming in, right? So you're going to know different location, different IP address, maybe different devices. You're going to step up MFA. It's a must. You cannot have authentication on API without MFA. And you're going to recognize right away that the guy cannot take care of the MFA because he doesn't have the phone, the mobile device of the real user for that MFA, maybe a FIDO2 key or push notification or a simple bio on the phone. So it's a really good way to get rid of hackers that have stolen credential attacking your APIs. All right, so thank you, Manoj, for this. I'm going to go back to the next big question, right, which is ultimately the subject. Both of you have an amazing experience doing things at a scale that I don't think anyone has really experienced before. So when you look at API and the security of an API environment at scale, thinking multiple clouds and data center, what are the things that are most critical to pay attention to? Do we start with you, Param?
Yeah, sure, Bernard, and thanks for the question. It's one of the favorite part of my job when I was looking at this area. So when you're dealing with scale, and in my experience, I'm sure same with Manoj, we were looking at billions of communications happening in a given year. The first and most important thing to look into is, do we have visibility to that scale? Do we know all the APIs that are out there that need protection? And one of the challenges the companies typically see is these APIs, because they are being developed by multiple teams on multiple platforms in a very hybrid cloud use case, that consolidated visibility is hard. So getting that visibility in a common plane of glass is very important for us to govern it more effectively. The other challenge that companies typically have is that the whole process of developing an inventory of API. So we know there's a place to go and look at all the areas where we need to apply governance is a very labor intensive work. The count of APIs is very hard. The velocity of APIs is in milliseconds, and so the traditional approaches do not apply. And for that, the companies have to really think about how do they automatically start discovering these APIs as and when they get created by these distributed teams on distributed platforms. They're not waiting to do that process manually, and automatically start cataloging them in a way that makes relevance for the company, so they can start attributing ownerships and response processes to those APIs more effectively. So having that combined visibility, having that quick automated discovery, automated cataloging really can help drive APIs at scale, specifically when you do not have full visibility to all that is being done in shadows or in siloed organizations.
Yes, thank you very much, Param. Manoj, what about you? I know at one time you were running an extensive environment with three clouds, two data centers, and doing the monitoring of all those API across all of those environments. What are the things you recommend people pay attention to when they look at that kind of scale?
Totally agree with what Param has shared. If I were to add, she covered quite a few aspects there. If I were to add any additional details, right? One is in addition to automating visibility, automating cataloging, right? I would also automate governance, because if you have to scale, if the right naming conventions or if the path collisions are happening right from the ground up. You want to automate the governance aspect, because you have small teams, and manually reviewing each of those API definitions would be difficult. So governance automation is another area. And Bernard, you are very familiar with the infrastructure we put in place at my previous place, where we synchronized the attack information or API usage information across all the clouds and data centers and colo centers. That way, if there is any issue or threat that was detected within one colo or cloud, the information is simultaneously synchronized at other clouds as well, so that it's more near real time. We leveraged combination of Mongo, DB, and some replication strategies that your team has suggested to get that in place. But having that API usage patterns and attack info synchronized across multiple clouds and colo centers was extremely important to address the scale associated with API security.
Yeah, thank you, Manoj. And then, you made me think of something, right? Because regarding governance, everyone is tracking API at a gateway level. Sometimes they see the user at the gateway, but across all the clouds, data center, they only see IP addresses. Maybe they see token or as tokens. And being able to associate all of the traffic across the cloud and the gateway to actual users and user identity is really critical for governance. Otherwise, all you have in your reports is a bunch of IP addresses and tokens, but how do you make heads from tail? So having a solution that lets you associate all that traffic to human being or devices across all. An example, you may have a bunch of APIs in AWS or GCP or Azure. You may have some in data center 1, data center 2. A user is accessing APIs across using multiple tokens, multiple IP addresses. Can you tell, right? Can you tell that this is a one user here that was accessing this AWS API and this data center in Houston at the same time with two different machines? Right? And is that okay? Is this normal? Is it not normal? Is this a hacker? That's why you need to tie everything to the user. So we're getting real close to the end of our session. Before we end, I just wanted to bring up a couple of slides that Manoj and Param and I had put together for you. A quick set of recommendation that things you need to think for in dev, right? Most important thing first, assemble a team to oversee API security. I'm not going to go through all of those. I think we touched on most of them during the talk, right? But assemble a team to oversee API security, get some funding, and then apply best practices in dev. And then once you're in production, right, you need to really think about a few more things. One thing we didn't talk about is the problem with bots on API. So you need a good anti-bot, right? And I think we touched on everything else here. And simply good practice, right? These are the 101 of what you need for securing APIs. So before I completely run out of time, I want to thank Param and Manoj a lot. It was really great to have both of you with us, sharing your experience with the audience. I'm sure they appreciated it. And I know there are very few people out there, right, that have the level of expertise that both of you have. So thank you very much for joining me, and goodbye to everyone.
Thank you, Bernard. Thank you, Manoj.
Thank you, Bernard and Param. Thanks for having me.
Take care.
Thank you.
Bye.